Hey everybody, it's Dynamic Math here. Just wanted to show you an example, a really powerful example of how GeoGebra can be used to foster discovery learning for students within the mathematics classroom. Second bullet, to engage students within meaningful remediation. The third component, to serve as an effective tool of differentiation of instruction. And last but not least, to serve as a source of ongoing formative assessment. Now, this applet here is the first applet in this worksheet. There's two of them. We're going to look at the first one together, and then afterwards look at the second, just so you can see how naturally we gradually release responsibility to the students and have them take charge of their learning. Now, it's up to you, the teacher, to give a reason for why we want to learn something like this. I often use an example of latitude and longitude. Well, where in the world are you? I mean, 40 something degrees north and how many degrees east or west of the prime meridian, right? Well, those two numbers, your GPS gives you, those are your coordinates, right? And a coordinate is simply a number that tells you your location. So, if you imagine all the circles of latitude around the globe and all of the half circles of longitude, and then peel that off the world and paste it flat, well, you get something that looks like this here, the coordinate plane, where like the x-axis serves as your equator and the y-axis serves as your prime meridian, if you will. And yeah, we have quadrants, 4 regions of the world: northwest, northeast, southeast, southwest. Talk about that. But actually applying it, I mean, like when you want to look up directions to go from Main Street to another street locally in town, well, how does Google actually figure it out? Well, I actually have students come here, and I'll just pose a problem. I mean, let's suppose, for example, you can play with this applet if you want. Let's suppose we're at a point, say 1, 3. The grocery store is there, for example, and and then I walk in a straight path to say negative, I don't know, maybe 7, 1, right? And I want to know, what's the direct line of sight distance there? Any ideas? I mean, what do you guys think? And I'll have kids take wild guesses, but how do we calculate that? Well, not really sure. Now at this point, I see a lot of teachers actually start writing a formula down on the board, and I think that's where the damage is done right there. D equals the square root of x sub 2. No. Let's stop and hit rewind. We want students to become masters of underlying concept, not masters of procedure only. Because how many of you teachers, I know, and I've been guilty of this too, right? We write the distance formula on the board, and then even if kids can substitute into the formula correctly, it then becomes a butchering of the order of operations. Don't want that. But let's take a look here. I want to find the distance from here to here. How can I do that? Give me a hint. Click the Show Hints button, and then I'll ask students, now does it look familiar to you? And then light bulb, goes off. The Pythagorean theorem, right? Leg squared in a right triangle, the leg squared plus the other leg squared equals the hypotenuse squared. By the way, don't call them A, B, and C, because all it takes is to, label the red, the run there C, and then, how many students get the, mess it up. But again, meaningful learning. Again, students have to dig back to their prior knowledge. They've all seen the Pythagorean theorem how many years, when they're in high school, and like how many times have they worked with it, but yet they often forget it. Well, this is a great visual reminder, but it's a meaningful reminder. And so therefore, this can be used to discover and say, wow, you know what? There's really nothing new that we're learning here. I mean, yeah, it's just in the coordinate plane, but finding the distance between 2 points in the coordinate plane is just a mere application of the Pythagorean theorem in most cases when that segment's diagonal. So regardless here, we can just have the student, well, yeah, 2 squared plus 1, 2, 3, 4, 5, 6, 2 squared plus 6 squared equals distance squared, solve it out, and here's where component 4 comes into play, the formative assessment. Well, how did you do it? Well, you can click, it'll actually show you the actual exact distance in simple radical form, and also, in this case, to the nearest hundredth. So, depending on what you as a teacher emphasize, and you could use this to your advantage. Now, you can generate different sets of problems, of course. Now, again, these distances will change, of course, as these points move around the coordinate plane here on the screen. But bottom line is that, you don't need to teach them a formula at all. I mean, you can have them discover it. I mean, if you look at this carefully, you can use this within the class and outside of the class. Why not on the first night give them a few homework problems if you're one of those teachers that gives homework, and ask them to find the distances between different pairs of points, but use this applet to help you confirm. Again, the students are still expected to show their work. They can't just write an answer. But they do the work on their own piece of paper. But I do expect to see a right triangle drawn with the legs labeled and the Pythagorean theorem done out correctly. Okay. Now, I've had students actually work with this applet on several problems in class, but then you'll have some kids that are kind of getting bored. They get it. You know, any problem you give them, they'll get it right. And so naturally, well, not every student's on the same page at the same time, so, and there lies with your differentiation. You want to make the learning personalized for every child, to meet them where they're at. Well, and this is where you can actually have them visit the second applet right after the first. Now, I've taught classes where I've had kids working with different sets of applets, you know, within the same class, and you can do that. That's okay, you know. But I'll refer the students here and ask them the same question. Well, hey, let's say, for example, can you find the distance between the ordered pairs, the points 4, 6, and say, I don't know, 0, 2? And students are like, I don't, not quite, or say 5, 6, and 0, 2, right? Not quite sure. Well, let's just show the hint, right? Now, I love this applet because the grid lines are missing, and it actually forces students to think spatially, like where do these points lie with respect to the other points, right? I mean, first quadrant, and there's a point in the y-axis. They almost have to see the axes. They're invisible. But check it out. Students, I mean, that is the triangle. I'll have the kids sketch it, and then I tell you what, I'm not going to tell you squat, so why don't you click the hint there? Maybe you can tell me now. I mean, there's that green component there. We call that the rise, or actually the absolute value of the rise, since technically we're finding a distance, and distance is not negative. Absolute value of a quantity is never negative, right? So I ask students, what is that distance? And oftentimes they might have a hard time telling me. And I said, well, just check out the left side here. Look at this. From you know, 2 feet above sea level to 6 feet above sea level here, how far did I actually rise? And usually most students are able to tell me, well, 4. And then I ask, well, how'd you get that? Oh, it's just 6 minus 2. And I said, okay, why don't you jot that down on your paper? 6 minus 2 is 4. Okay, well, let's show the second hint now. All right, well, here we're starting coordinate of 0 and ending coordinate of 5. How far from 0 to 5? Oh, Mr. B, that's just 5. Well, how'd you get it? Well, we subtract. I mean, or I might not give them a problem where the coordinate 0. I might do something like this so they see they have to physically subtract. You know, 5 minus 1 is 4. Some students who subtract the other way, 1 minus 5, well, that's a negative 4, but hey, we're taking the absolute value of that run, right? So it's going to be 4 no matter what. So, but back to the old problem, right? So they draw the triangle out, get the 2 legs, do the Pythagorean theorem, and, you know, lo and behold, they can actually show the distance here. And in this case, we get the square root of 41, or roughly 6 4/10. So, you know, each student's going to learn at a different rate. You as a teacher know that. It's common sense. But where GeoGebra has the power to do and come in is actually be able to meet every student at their appropriate ability level. Like, you're going to have some kids in your class that won't get beyond this, and you know that. You can count, you know who those kids are. But for the students, why should the students who know what's going on be bored? Why not give them a challenge and see if they can actually write a relationship themselves? That is, the absolute value of the run squared plus the absolute value of the rise squared gives you the distance squared. See what I'm saying? So, you know, applets like these you could use to students' advantage, and, you know, for discovery learning, hence this applet for discovery learning, the first one, you could use this for meaningful remediation, especially when they struggle. Oh, wait, how do I plot a point again? You know what those students are. I have them too in my classroom, right? And then to differentiate, well, I have some kids here, some kids over here. And finally, formative assessment. Well, how did I do? Did I actually solve for the distance correctly? Okay, this informs your instruction, obviously, and it also informs the student, more importantly, of how they're progressing in terms of demonstrating mastery of the objective of being able to calculate the distance between 2 points within the coordinate plane. Okay, so again, this is just but one of many examples you could find within this worksheet here of the CCSS High School Geometry book. I love creating applets like these because I want students to take the driver's seat, and I want them to be able to discover and have them be able to tell you, the teacher, how the underlying workings of the mathematics that they're actually discovering. Okay, so if you have any questions, feel free to email, give a shout out. I'm on Twitter, Facebook, you name it. Contact information can be found in the link below these applets, and hope you enjoyed it. And again, hope it you know, gives you ideas. And the cool thing here is that you could take any one of these worksheets you find from anybody, and you can hit make a copy. If you go to the upper right hand corner of your screen, there's 3 dots. Hit make a copy, or you can download it, and you can actually tweak it to make it look the way you want. That's what the beautiful part of what Creative Commons is all about. The license there. This is all free. So hope you take it, enjoy it, and hope you enjoyed watching. Have a good one.